Hey guys, we're going to start polar area today. We're going to continue our journey of polar equations. I'm going to kind of chunk this together for you. So we're going to start off by doing example 1. Now this says find the area of one petal. So the area of one petal. And it gives us our equation r equals 3 times the cosine of 3 theta. Okay, so first of all, what shape is this going to be? And I think it kind of gives it away when it says a petal, but it's going to be a rose curve. It's a cosine, so it's symmetric with the x-axis. And then the 3 is odd, and so there's 3 petals. Okay, when I make my chart, r and theta, since this is a 3 theta, I want to do 0 and pi 6. Pi thirds, pi halves. So I'm doing all of the pi 6 around the circle. Okay. When I plug in a 0, I get the cosine of 0 is 1 times 3 is 3, and then 0. And then when we do the pi thirds, we get the cosine of pi is -1, so that gives us our -3, and then we get 0. So when I graph this, I know I'm going to the angle 0 and 3 circles out and then back. Okay, and then this is pi thirds, but it is a -3, so pi thirds is up here, but since it's -3, I would go 1, 2, 3 this direction. Okay, so our next one is going to be right here and then back. So I've drawn this one and then we draw this one. They should be the same size. And then if it's symmetric with the x-axis, then I know there's going to be another one that's going to be at pi thirds, not pi thirds, but pi thirds away from the x-axis. So this distance is pi thirds and this distance is pi thirds. And we create our rose petal curve, okay? So this wants to know the area of one of these petals. And we know that this angle, because of this, is pi 6. So I'm kind of looking at this and this. So this would be negative pi 6, and this would be positive pi 6. I'm going to go from the origin, and I'm going to do a fan like this and figure out what the area is in between. Now, what I want you to notice is that these two are symmetric, right? It's symmetric across the x-axis. So technically, if I went from 0 to pi 6 and I doubled it, that would be the same as negative pi 6 to pi 6. So let's set that up for a minute. So our area formula for polar area is 1/2, and then the integral from our two angles, so negative pi 6 to positive pi 6. And then r, we already know, is 3 cosine of 3 theta, but r is going to be squared, which means this is also going to be squared. Okay, so you could write it like that, or you can put it all in parentheses, whichever way you prefer. So if I instead went 1/2 and I doubled 0 to pi 6, then I can get rid of this first 1/2, and then I get the 3 squared cosine squared of 3 theta d theta, okay? So this is what we're going to be doing here. So the area from 0 to pi 6 of 9 cosine of 3 theta squared, okay? So if I can use a calculator, I can just plug that right in and get my area. But if I have to do this by hand, I have to use an identity that tells me that the cosine squared is equal to 1 plus the cosine of 2 times that angle, whatever this was, is going to double. And then the whole thing is divided by 2. Okay, so if I replace that, then I'm going to have 9, and then 9 is going to multiply. I'm going to replace this with this. I shouldn't have put the d theta in there. So 1 plus the cosine of 2 times this is going to be 6 theta divided by 2. And then I could move this 2 over here. So we've got 9/2, 0 to pi 6, 1 plus the cosine of 6 theta. Okay, so we started off with figuring out the boundaries, the limits of integration. Okay, I know this is symmetric, so I doubled it, which got rid of that 1/2. And then I went through and I used this identity, the cosine squared, and I replaced my cosine squared in my function, and this is our simplified form. So now I'm going to take this integral. So I get 9/2, and the integral of 1 is just theta, and the integral of the cosine of 6 theta is 1/6 times the sine of 6 theta, and that's evaluated from 0 to pi 6. Okay. Put a pi 6 right here, and a pi 6 right here. Then I'm doing the 1/6 times the sine of pi, which is 0. So this just becomes 0. So when I plug pi 6 in, I get 0. And when I plug 0 in, we also get 0. So our answer is going to be 9 pi over 12, which is 3 pi over 4. Okay, and you could check that by plugging that in your calculator, and you'll see that it does give you the same answer, which is 2.356. All right, so for polar area, we have our formula for polar area is 1/2 times the integral, and we don't just use a and b because these are angles, so they do alpha and beta, but it just means the limits of integration of r squared d theta. Okay, this is our flashcard. Polar area equals this. We have to have this memorized. Okay, and then this one could be a flashcard too, where you write this equation down, and then on the back you write down what it's going to look like. And then we have to know this trig identity. I can spell identity. Okay, to do that one and a couple of other of these. All right, so that's the first example. We will continue on in the next video.